Assalamualaikum. My name is Ahmad Daniel bin Muhammad Fauzi, and my metric card number is CE180085. So today I'm going to explain the introduction for experiment 5. In this experiment, we have exposed on the accurate measurement of a resistance can be performed by using an impedance measurement bridge. There are many electrical bridges, usually identified by the name of the inventor, to the measure different types of resistance and impedance. The basic bridge circuit, the Wheatstone bridge, is suitable for measuring mid-range resistance. In this case, a DC voltage source and a DC meter can be used because the impedance to be used in real. The Kelvin double bridge is an improved Wheatstone bridge which greatly improved the accuracy of measuring low value resistance. Usually it is less than 1 ohm. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazim bin Sardin and my notice card number is C180160. Today I will explain about the simulation for the lab experiment. First of all, for the first activity, this is the process that I need to run the simulation for circuit that given in the lab sheet. This is the value for all the components, and the potentiometer I set to 14% to get to the nearest value of 0 at multimeter. I get the 3.098 microamp. Then I have to set to the new value of Rx. I set to 2.2 kilo ohm, and the value for multimeter has been changed to 265 microamp. Then the potentiometer I set to the new to 66%, and this is the new value for multimeter, 8.05 microamp. For the second activity, as we can see, in open mode, I got the millivolt meter reading 0 millivolt. This is when during the all the components for RA and RB 1000 ohm. In closed mode condition, I changed the RB into 965 and the other one is 182 ohm. The new value of millivolt meter reading is almost 0 millivolt, and the unknown resistance value is 0.01018, same as shown here. Then if I change to the new value, the load resistance here I change from 0.01 ohm into 0.001 ohm. This condition in open mode, I got the 2.499 millivolt, and in closed mode condition, I change the RB into 30 ohm, and the other one is 29.1 ohm. Then a new value for unknown resistance is 0.03436 ohm, and the millivolt rating is also almost 0.00018. So this is how I simulate for the Proteus and this online Kelvin double bridge simulator. So that's all for me for simulation for this experiment. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman Muhammad Fazil. Today I will present to you about discussion and question for our lab experiment. So for activity 1 is about Western Bridge. So after we have done this experiment by using multi-sim software, we can get this value of resistor R3 and ammeter reading by adjusting the arm of R3 until it get near to the 0 microampere. Okay, after that we take the value. So after that we can also calculate by using the equation at the left sheet, which is Rx equal to 924 ohm. So after that the summation is repeated, which the R4 is set at 2.2 kilo ohm. So after that we take all the parameters into this table, as you can see at this table. So for activity 2 is Kelvin double bridge. So Kelvin bridge is there's a 2 mode. So first of all we need to set at 12 volt. After that the thermostat need to adjust it until the ammeter reading is set to 2 ampere. So after that we can take the value of the thermostat, which is num ohm. So millivolt meter reading is 0 millivolt. As you can see, RA, RB, RA, and RB is 1000 ohm. So as you can see, after that which is closed mode, this value for the closed mode, and the unknown resistance can be calculated by using the equation. This the calculated unknown resistance value. The unknown resistance is found from the simulation. Okay. Okay. After that, we repeated the procedure, same with the first of cabin double bridge, which we change to S to the 0.001. So this is the answer for this for the second simulation. So for the question 2, the answer is the calculated value of resistance for both circuit also provide more accurate reading. So calculated value provide more accurate readings than the simulated value due to error. For the question 3, percentage of error. So these are there are 4 error in both circuit. So the difference between the true and terma of the value of 3 resistance can cause the error in measurement. Second, the manometer is less sensitive, thus accuracy occurs in the balance point. Errors due to the overheating in the element in the arm of the bridge. Errors due to the effect of magnetic cable and lead shortcut. So the Wheatstone and the Kelvin double bridge is the same circuit, but Kelvin double bridge is modified of Wheatstone bridge. So they are likely the same. So for the accuracy of the Wheatstone bridge is 0.1%, while the accuracy of the Kelvin double bridge is plus minus 0.05% to 0.2%. So for question 5, which bridge that can measure the 50 kilo ohm. So for high resistance measurement, potential is used to obtain sufficient current and galvanometer detection. As a result, leakage current will also increase. In order to avoid the leakage current effect in the measuring circuit, the circuit are generally used. So the resistance to be measured is mounted on 2 insulating posts, which in turn are mounted on metal platform known as a guard point. So for the last question, is question 6. How I know the unbalanced condition, and what's the parameter that can be used to measure, by the unbalanced condition. So how to know the unbalanced condition is V out in the circuit is not equal to 0. Resistance is said to be an unbalanced Wheatstone bridge. So if V out is equal to 0, that is unbalanced. So after that, usually the unbalanced Wheatstone bridge is often used for measurement of different physical quantities like pressure, temperature, and strain. That's all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris bin Muhammad Yazid with metric number DE180161. So today I'm going to proceed with the experiment presentations. So in the experiment, I am going to present regarding the conclusions. So in experiment 5 entitled Measurement Using DC Bridge, we can conclude that we could verify the resistance measurement technique using the Wheatstone bridge and the Kelvin double bridge. The measurement through the Wheatstone bridge is suitable for measuring the medium range resistance, and measurement through the Kelvin double bridge is suitable for measuring low level resistance due to the increased accuracy. Furthermore, we were also able to determine unknown resistance using the Wheatstone bridge and Kelvin double bridge in simulation. Lastly, we compared this resistance measurement between the Wheatstone bridge and Kelvin double bridge based on the simulation value through the simulation applications. So that's all from me. Thank you, and Assalamualaikum warahmatullahi wabarakatuh.